Let's see leetcode problem 162, find peak element. First we will discuss and understand the problem statement, and then we will discuss and understand the approach. First approach is brute force approach and second approach is an optimal approach, and then we will try run the code also. So let's start. Let's understand the problem statement. So we have to find the peak element. Okay, first of all I will tell that finding peak element is not equal to the finding largest element. Okay, this is a one problem, okay, everyone face, okay, while starting by seeing the example. Okay, so I will clarify that first of all the peak element is not equal to the largest element. Okay, so here is input nums and output is 2. Okay, so here index 0 1 2 3 3 is the peak element, so output is 2. Okay, so here 6 is peak element, so output is its index 0, means 5. Okay, so I will teach you the means I will tell you the problem statement. Okay, so here peak elements means what? This nums is given. Okay, so here we will plot it. Okay, then we will understand it visually. Okay, so here 1 2 1 3 5 6 and 4 is given. Okay, so what is peak element? Peak element is the greatest element among the its neighbors. Okay, so its neighbor should be right neighbor and left neighbor should be smaller than it. Okay, so here 2 is also peak element. Okay, because 1 is smaller than it, and here 1 is also smaller. Okay, and here 6 is also a peak element because its neighbors are smaller than it. Okay, so what is meant by peak element? Peak element means the largest element between the two neighbors. Okay, so this is a peak element, not the largest element. Okay, in this array largest element is 6. Okay, but here peak elements are 2 and 6. Okay, you can also return 2, you can also return 6. Okay, so 2 and 6 both are the valid for this problem. Okay, so here one more example I will give that 1 2 1 3 4. Okay, so here also 2 peak elements are there, 2 and 3. Okay, because these are greater from their neighbors. Okay, so here valid answer is 2 and 3 both. Okay, so you can return anyone. Okay, so this is peak element. I will say that you have understand the problem statement. Okay, so let's understand the approach. Okay, approach is very simple. Okay, we will use the binary search algorithm. Okay, before I have teach the binary search algorithm, you can refer my video. I will give the link in the description. Okay, so you can watch the binary search algorithm if you don't know. Okay, if you know it properly, then you can directly jump to this problem. So this is given number. Okay, nums array. Okay, so what we will do, simply we will put the two elements. Okay, like means like binary search only. Okay, so here is a dry run of code. I will teach by dry running code. Okay, so here is L and here is right pointer. Okay, so we will find the mid and we will check the mid plus 1 is greater than the mid. If it is yes greater than mid, then we will simply increment left pointer next to the mid. Okay, so mid plus 1, so our left pointer will come here. Okay, now we will calculate mid will come here. Okay, now we will check mid plus 1 is greater than the nums of mid plus 1, it is not greater than this one. Okay, so what we will do, simply we will decrement the right pointer towards the mid. Okay, so right will come here. Now what we will do, simply we will check the now we will calculate the mid. Okay, so mid will come here 0 1 2 3 4 5 and 6. Okay, so 5 minus 4 which is equal to 1. Okay, 1 divided by 2 which is equal to 1 only. Okay, sorry 0, and 0 plus 4 is equal to 4. Okay, so mid will come here. Okay, simply mid will come here. Okay, now what we will do, simply mid is here. Now we will check mid is greater, if next element to the mid is greater, 6 is greater than 5. So what we will do, we will increment left pointer next to the mid. Okay, so left will come here, and simply we will check is left less than right. It is not less than right, it is equal to. Okay, so it condition not satisfied, so directly we will return left, which is an 6, means index is 5. Okay, you will not understand directly approach, so I will dry run the code, and while dry running the code you will understand better. Okay, so let's dry run the code. Here you will understand most properly. Okay, so here is a left pointer at 0, right pointer is at last. Okay, and we will calculate the mid formula is this one. Okay, so left plus right minus left divided by 2. Okay, we will use this, not if this right plus left divided by 2. Okay, this will apply on the smaller arrays. Okay, as we go towards the larger arrays, it will not calculate correctly mid. Okay, to avoid the overflows, we will use this formula. Okay, it is similar to this only. Okay, so left is less than right, 0 is less than 6. Yes, now we will calculate mid. left is 0, 6 is right, minus 0, which will come 3. Okay, so mid will come here. Okay, now we will check nums of mid, means 3 is less than nums of mid plus 1. Nums of mid plus 1 means here, okay, 5. 3 is less than 5, yes, it is less than 5. Now simply we will increment the left. Okay, so mid plus 1, we will do left is equal to mid plus 1. So left pointer will come here. Okay, left pointer will come there. Okay, now again we will iterate, and now we will check 4 is less than 6, yes, it condition satisfies. Okay, now we will come inside. Now mid is equal to left plus, okay, so left is 4 and right is 6 minus 4 divided by 2. Okay, so this will come out as 6 minus 2, 2 divided by 2, 1 plus 4, which is equal to 5. Okay, so mid will move here. Okay, now again we will come up. Okay, no, sorry, mid is here. Okay, now we will check nums of mid is less than nums of mid plus 1, means here 6 is less than 4, no, it is not less than 4. So what we will do, simply we will come in else part and we will move decrement our right pointer, okay, towards mid. Okay, so r is equal to mid, so r will come over here. Okay, so r is get cancelled. Okay, again we will come up and now we will check 4 is less than 5, yes, it condition satisfies. Now what we will do, we will calculate again mid. Okay, so left pointer is 4 and right pointer is 5, which is equal to minus, okay, 4 and divided by 2, this will come out. Okay, this answer is 5 divided by 4, which is equal to 1, 1 by 2 is 0. Okay, so 4 plus 0 is 4. Okay, now mid is 4. Now mid will become here. Okay, now I will draw here new array. Okay, means you will understand better. So I will write here like this: 1 2 1 3 5 6 and here 4. Okay, so here I will put index number 1 0 1 2 3 4 5 6. Okay, now our left pointer is here and mid is here and right is here. Now what we will check is nums of mid is less than nums of mid plus 1. 5 is less than 6, yes, it is less than 6. Now what we will do, simply increment the left pointer. Okay, so left is equal to mid plus 1, left will be get cancelled and left will come here. Okay, now again we will iterate and now we will check is left less than right. Now left is 5 and right is also 5, left is equal to right. Okay, so in our condition, so it will not satisfy this condition and directly else while loop will be exited. Okay, and we will return the left. Okay, so at last left is 5. Okay, so we will simply return the index number 5. Okay, and in this peak element is 6. Okay, index number 5. We can also return 2. Okay, but we are finding the maximum peak element. Okay, in this problem you can also return 2. Okay, so I am returning 6 here. Okay, so this is a very simple approach. So let's see, I hope that you understand the dry run of code and approach. If you not understand this code and approach, then you so first we will take the left pointer. Okay, left is equal to 0 and right is equal to nums dot length minus 1. Okay, now we will take the while loop. Okay, so while left is less than right, then we will calculate the mid. Okay, so int mid is equal to left plus right minus left divided by 2. Okay, now we will check if nums of mid is less than nums of mid plus 1. Okay, then we will simply increment the left pointer. Okay, so left is equal to mid plus 1 and else we will decrement the right pointer. Okay, so right is equal to mid. Now simply what we will return, we will return the left pointer. Okay, so return left. So let's compile the code. Okay, here is a compilation. Okay, left not yell. Okay, so let's compile the code once again. Okay, our code is successfully compiled, so let's submit the code. So thank you guys for watching my video. If you liked my video, then like, share and subscribe. And this was our day 50 of 100 days of code DSA challenge. Okay, so you can see here our code is successfully submitted. Okay, so beats are 100%. Okay, so thank you guys for watching my video.